stars are big, like really big. But how do we know that they look so small from Earth? Good question. Until recently, the only accurate way to measure the mass of a star could only be done in binaries or double star systems, which is basically two stars orbiting the same thing, whether that be a planet, a moon, or even another star. They also take the orbital velocity and the orbital period just for good measure. What does all that even mean? Think of it like a NASCAR race. The orbit of the star is how long the track the cars are racing on is. The orbital velocity is how fast the car is going, and the orbital period is how long that car takes to make it around the track one time. After they have all that information, they use the equation orbital velocity equals the square root of gravity times mass divided by radius, or V equals the square root of gm over r. If you take in high school or college physics, you've probably heard of this and it sounds super familiar. Thanks Isaac Newton, just shift around some numbers, then boom, you have your mass. But what happens if a star doesn't belong to a binary, like most stars in our solar system? Do we just not know the mass of that star forever? That's where our friends at NASA come in. Thanks to them, we now have a new, more accurate, and more complicated way to calculate the mass of a star. In big words I personally don't really understand. They use the total light from the star and its parallax to infer its diameter. Then, the way the light from the star flickers is analyzed to get the surface gravity. Finally, those two things are combined to get, you guessed it, the star's mass. Now to simplify it, because my brain is working double time after that. A parallax is the angular difference in direction of a celestial body as measured from 2 points on Earth's orbit. Simply put, they measure a star's apparent movement against the background of more distant stars as Earth revolves around the Sun. This phenomenon is called gravitational microlensing. Using the Hubble Space Telescope, our NASA buddies can calculate that, and after some analysis, they have the mass. This idea was originally thought up by Einstein himself in his theory of relativity and how massive objects warp space. And Arthur Eddington originally first proved this method in 1919 with a solar eclipse. Today, we have our own scientists at NASA using this method to find the weight of white dwarfs, although the opportunity to use gravitational microlensing doesn't come often, since you have to wait for the object you're weighing to pass in front of another star. Gravitational microlensing can also be used to calculate how far the stars are and to find exoplanets. But that's a video for another day. For now, shoot for the moon. Even if you miss, you'll land among the stars. Actually, you probably won't, but that's not very inspirational now, is it?